morning children. In our second chapter polynomials, we are going to solve our next exercise problem based on factorization of polynomials. Okay. So before going to the factorization of polynomials, we have to know what is meant by the factor of the polynomial. Already we have solved the problem based on factor of the polynomial. First, let us see the factor theorem. If p of x is a polynomial, if p of x is any polynomial of degree greater than or equal to 1, the degree greater than or equal to 1, and a is any real number, a may be any real number. First case, x minus a is a factor of p of x if p of a equal to 0. The first case is x minus a is a factor of p of x in the case if p of a equal to 0, and also if p of a equal to 0, see here, if p of a equal to 0, if x minus a is a factor of p of x, okay, it has given in the form of vice versa. X minus a is a factor of p of x if p of a equal to 0. Next one, p of a equal to 0 if x minus a is a factor of p of x, okay. So we know that a polynomial, okay, p of x, if you are using the remainder theorem, if you are dividing a polynomial by another polynomial, we use the remainder theorem in our previous exercise. So what is the remainder theorem? Okay, we are going to prove this factor theorem by remainder theorem. See now, by the remainder theorem, p of x is a polynomial. P of x is equal to x minus a into p of x plus p of a. This is nothing but dividend equal to divisor into quotient plus remainder. That states the remainder theorem, isn't it? So p of x is equal to x minus a into p of x plus p of a. Using this statement only we are going to prove. Okay, we are given two cases. See here the first case, x minus a is a factor of p of x if p of a equal to 0. Now listen. So in the remainder theorem, if you are taking if p of a equal to 0, the first condition p of a equal to 0. What is p of a here? It is the remainder. So the remainder, if the remainder is 0. See here, if the remainder is 0, p of x is equal to x minus a into p of x, and the remainder becomes 0. So p of a is not written here. So p of x is equal to x minus a into p of x. See here, p of x is in the product of two variables. So surely x minus a will be one of the factor of p of x. Okay, so the remainder becomes 0. So we got p of x is equal to x minus a into p of x. Surely x minus a will be the one of the factor of p of x. So we can say that x minus a is a factor of p of x. What is the second case? If x minus a is a factor of p of x, p of a equal to 0. If x minus a is a factor of p of x, p of a equal to 0. Okay, if x minus a is a factor of p of x means we can substitute the 0 of the factor. Okay, what is the factor here? X minus a. So x minus a is the factor of p of x. What is the 0 of x minus a? It is a. X minus a equal to 0 means x is equal to a. So the 0 of x minus a is a. So we are going to substitute the value of x equal to a in the given equation. See here, we are going to substitute here. Instead of x, we are going to substitute a. See here, p of a is equal to, instead of x, we are taking a minus a into g of x. G of x may be in equation. Okay. So what is a minus a? 0. 0 into any number is 0. So finally we got p of a equal to 0. So if x minus a is a factor, then p of a equal to 0. So see the factor theorem. They have given the two cases. If x minus a is a factor of p of x, if p of a equal to 0. Okay, so if you put p of a equal to 0, we got x minus a is a factor of p of x. Other case, if you are taking x minus a is a factor, we got the remainder p of a equal to 0. Okay, that's the factor theorem. So we are going to solve our fourth exercise based on factor theorem. Okay, now the first problem. Determine which of the following polynomials has x plus 1 pure factor. Okay, so we have to determine whether x plus 1 is a factor of the given polynomial or not. When we say the given x plus 1 is a factor of the given polynomial, if you are substituting the 0 of x plus 1, okay, when you are substituting the 0 of x plus 1 in the polynomial, and if you are getting the remainder 0, if you are getting the remainder 0, then we can say that x plus 1 is a factor of the given polynomial. This is the concept of factor theorem. Yes? Now listen how we are going to solve the problem. In the first subdivision, we are having x cube plus x square plus x plus 1. Okay. So what is the question given? X plus 1 is a factor or not? We have to determine whether x plus 1 is a factor or not. First, take limit. P of x is equal to x cube plus x square plus x plus 1. Take the given polynomial as P of x. Next, we are going to find the 0 of x plus 1. What is the 0 of x plus 1? How you will find? Just equate to 0. Okay. So if you are equating x plus 1 equal to 0, the value of x is equal to minus 1. So this is called as the 0 of x plus 1. So the 0 of x plus 1 is minus 1. Have you understood how to find the 0 of x plus 1? Just equate x plus 1 equal to 0. The value of x is equal to minus 1. That is the 0 of x plus 1. Okay. So here the 0 of x plus 1 is minus 1. So according to factor theorem, we are going to substitute or replace x by minus 1 in the given polynomial. Okay. We are going to replace the value of x by minus 1 and we are going to check whether the remainder we are going to get 0 or not. If it is 0, then we can say that x plus 1 is a factor. If the remainder is not 0, then x plus 1 is not a factor of the given polynomial. Yes. Let us check. Now, we are going to substitute minus 1 instead of x, isn't it? So, p of minus 1 equal to, in the first term, here it is x cube. So, instead of x, we are taking minus 1. So, minus 1 the whole cube plus next term x square. So, minus 1 the whole square. The next term is x. So, plus minus 1 plus 1 is minus 1 whole cube. It is an r power. So, it is minus 1 plus 1 square minus 1 the whole square is 1 and plus into minus it is minus 1 plus 1. Yes. So see here plus 1 minus 1 will get cancelled, otherwise 1 plus 1 is 2 minus 1 is minus 2. In any way the result of this is equal to 0. So see here we have to determine whether x plus 1 is a factor of the given polynomial. We found the 0 of x plus 1, that is minus 1. We replaced x by minus 1 in the given polynomial and we got p of minus 1 equal to 0. So what is the conclusion? Here x plus 1 is a factor of this polynomial. So we can write that rule x plus 1 is a factor of p of x. The first subdivision we got x plus 1 is a factor of p of x. Let us check for the second subdivision, the same factor only. We have to check whether x plus 1 is a factor of p of x. In the first question itself, we have identified what is the 0 of x plus 1. The 0 of x plus 1 is minus 1. So directly you can check x is equal to minus 1 in the second problem. So for that, we are going to write p of x is equal to x power 4 plus x cube plus x square plus x plus 1. So what is the 0 of x plus 1? That is minus 1. So replace x by minus 1. So p of minus 1 is equal to minus 1 the whole power 4. Because the power is 4, x should be replaced by minus 1. So minus 1 whole power 4 plus minus 1 the whole cube. The next term minus 1 the whole square plus minus 1 last the constant term 1. Now find the value. Here it is even power, so minus 1 the whole power 4, it is 1 plus minus 1 the whole cube is minus 1 plus minus 1 whole square, it is plus 1 plus into minus here, you have to multiply, plus into minus is minus 1 last constant term plus 1. Now find the value 1 plus into minus will become minus 1. Again plus 1 minus 1 plus 1. Yes. So see here plus 1 minus 1 will get cancelled. Again plus 1 minus 1 will get cancelled. But what is the remaining answer? It is 1, which is not equal to 0. So check here. We are getting p of minus 1 is equal to 1. the value is not equal to 0. According to factor theorem, we have to get the remainder 0. Then only we can say that the given is a factor of the polynomial. But here we are getting the remainder 1. So what is the conclusion? X plus 1 is not a factor of p of x. So write that, therefore x plus 1 is not a factor of p of x. So from these two problems, I understood how to find or how to verify whether the given is a factor of the given polynomial. If x plus 1 is, we have to check x plus 1 is a factor of the given polynomial, means just find the 0 of the given and substitute in the place of x. If you got the remainder 0 means it is a factor. If the remainder is not 0 means it is not a factor of the polynomial. Let us check for the third subdivision. Okay, in the same way we are going to check whether x plus 1 is a factor of the given polynomial or not. For that, first let p of x is equal to x cubed minus x square minus 2 plus root 2 into x plus root 2. Okay, x cubed minus x square minus 2 plus root 2 into x plus root 2. Just replace x by minus 1 because the 0 of x plus 1 is minus 1. So we are going to substitute minus 1 for x. So minus 1 the whole cube minus 1 whole square minus 2 plus root 2 into minus 1 because into x, so we are putting into minus 1 plus root 2. Now solve it. Minus 1 the whole cube is minus 1 minus 1 the whole square is 1. Yes. See here we are going to multiply with this. Okay, you can take either minus inside and then multiply. Just multiply this because they are in product form, you know. So minus into minus will become plus. And 1 into any number, the same number, isn't it? So 2 plus root 2 plus root 2. Okay, see here we have multiplied the sign and 1 into the any number, the same number only. So 2 plus root 2 plus the constant number root 2. Now solve it. Minus 1 again minus 1 plus 2 plus root 2 plus root 2. Okay, so see here minus 1 is minus 2. Here it is plus 2. Root 2 plus root 2 is 2 root 2. Minus 2 plus 2 will get cancelled. So what is the remaining answer we are getting? 2 root 2. Now the result is 2 root 2. So what is the conclusion? Here the remainder p of minus 1 is not equal to 0. It is not equal to 0. We are getting the solution 2 root 2. So what the conclusion we can write? X plus 1 is not a factor of p of x. So you have to write x plus 1 is not a factor of p of x. So yes. So if you are given any other polynomial to determine whether it is a factor of another polynomial, means just find the 0 of the given factor or a polynomial and substitute in the polynomial. If the remainder becomes 0, okay, you can say that it is a factor. If the remainder is not a 0, you can say that it is not a factor of the given polynomial. Now the second problem, use the factor theorem to determine whether g of x is a factor of p of x. So g of x is a polynomial, p of x is also a polynomial. You have to determine whether g of x is a factor of p of x. Okay. In the first subdivision, p of x is given as x cubed plus 3x square plus 3x plus 1, and g of x is x plus 2. We have to determine whether g of x is a factor of p of x. So first, we have to find the 0 of. According to the factor theorem, we have to substitute the 0 of this in p of x. If the remainder is 0, then it is a factor. Yes. So we are going to find the 0 of g of x. What is the 0 of g of x? 0 of g of x is minus 2. How? We have to equate x plus 2 to 0. So what is the value of x? X is equal to minus 2. That is the 0 of g of x. So 0 of g of x is equal to minus 2. Now we are going to find p of minus 2. In place of x, we are going to replace the value of minus 2 and we are going to check the remainder. Okay. So now p of minus 2. So first term x cube. So minus 2 the whole cube. Second term 3x square plus 3 into x square. X square means minus 2 the whole square. Next term plus 3x. So 3 into x minus 2 plus the constant term 1. Now find the remainder. Minus 2 the whole cube. Isn't it? We have to multiply 2 for 3 times. 2 to the 4, 4 to the 8. So our power means it is minus 8. So you have to multiply 2 for 3 times. 2 to the 4, 4 to the 8. So it is minus 8 plus 3 into minus 2 whole square. Minus into minus will become plus 2 to the 4. So 3 into 4. Here 3 into minus 2 plus 3 into minus 2. Totally it will be minus 6. Plus into minus is minus 3 to the 6 plus 1. Yes. Now it is minus 8 plus 4 3 is 12 minus 6 plus 1. Yes. So you can just first add the two numbers and you can add the next number. Otherwise add the numbers which are in positive sign and in negative sign. Yes. So shall we do like that? So see here minus 8 minus 6. Minus 8 minus 6 is minus 14. Isn't it? I'm taking the numbers in negative sign. So minus minus means we have to add the number. So 8 plus 6 is 14 and negative sign minus 14. 12 plus 1. 12 plus 1 is 30. So what is the final value? Minus 14 plus 30 means it is minus 1. So here p of minus 2 is equal to minus 1, which is not equal to 0. Which is not equal to 0. Here we got the remainder as minus 1, which is not equal to 0. So therefore g of x is not a factor of p of x. Okay, have you understood why g of x is not a factor of p of x? Because the remainder is not equal to 0 and we got the remainder minus 1. So it is not a factor of p of x. Come to the next problem. Here p of x is equal to x cube minus 4x square plus x plus 6. And g of x is given as x minus 3. Again we have to check whether g of x is a factor of p of x. For that first we have to find the 0 of g of x. So 0 of g of x. What is the 0 of g of x? It is plus 3. Okay. So how? X plus 3, sorry, x minus 3 is equal to 0. Here x minus 3 equal to 0. So x is equal to minus 3 goes that way, it is plus 3. This is the 0 of g of x. Isn't it? Now p of 3. We have to substitute 3 for x in p of x. So replace. So here first term 3 cube minus 4 into 3 square plus 3 plus 6. See here 3 cube minus 4 into 3 square plus x plus 3 and the constant term plus 6. Now calculate the value. 3 cube. 3 cube means you have to multiply 3 into 3. What is the value? It is 27. It is 9 is 27 minus 4 into 3 square. 3 square is 3 3 is 9 plus 3 plus 6. Now 27 minus 4 into 9. Multiply the value. 9 4 is 36 plus 3 plus 6 is 9. Now add the terms, positive terms. 27 plus 9. What is the value of 27 plus 9? It is 36 minus 36. Here, if we are adding this, we are getting 36. Already minus 36 is there. 36 minus 36, the value is 0. Yes, we got the remainder 0. So we got here p of 3 equal to 0. So what we can say here, g of x is a factor of p of x. So you can write that therefore g of x is a factor of p of x. Okay, so in this way you can determine whether g of x is a factor of p of x or not. See the third problem. Find the value of k if x minus 1 is a factor of p of x. See here, we have to find the value of k if x minus P of x. In the last two problems, we verified whether some factor, okay, some given polynomial is a factor of the given polynomial or not. But in this problem, they have given that x minus 1 is a factor of P of x. It is a factor only. In that case, you have to find the value of k. Okay, suppose if x minus 1 is a factor of P of x means, what is the remainder? If you are substituting x is equal to 1 in P of x, the remainder will be equal to 0. Then only we can say that x minus 1 is a factor of P of x. Using that concept of factor theorem only, we are going to find the value of k here. So see, x minus 1 is a factor of P of x. What is the 0 of x minus 1? 0 of x minus 1 is 1. We know how to find the 0 of x minus 1. Isn't it equal to 0? So the value of x is equal to 1. So P of 1 in place of x, P of x, this is P of x given in the question. P of x is equal to 2x square plus ax plus root 2. So P of x instead of x, if we are replacing 1 once, it should be equal to 0. Automatically the remainder will be equal to 0 because in the question it is given that x minus 1 is a factor of P of x. So if you are substituting the 0 of x minus 1 in the given polynomial P of x, the remainder is equal to 0. Okay. Now substitute the value 1 in the given polynomial. So P of 1 is equal to 2 into 1 square plus k into 1. Just replace only x. You should not replace the value of k there. That is the unknown value. You have to find the value of k. So just replace the value of x. So 2 into 1 square plus k into 1 plus root 2. Or see here, P of 1 is equal to 0. You have to equate P of 1 to 0. So we are going to equate this value to 0. Because this is the value of P of 1 now, we are going to equate this to 0. Okay, now 2 into 1 square is 1. Yes? Plus k into 1 is k plus root 2 equal to 0. Yes? That is, we are having 2 into 1 square is 1 plus k into 1 is k plus root 2 equal to 0. What is the value of 2 into 1? That is 2 plus k plus root 2 equal to 0. What is the question? You have to find the value of k. So keep k here in your left hand side, take other values to the right hand side. So k is equal to, yes, if plus 2 goes that side, it will become minus 2. Also plus root 2 goes to the next side of the equation, it will become minus root 2. So we got the value of k is equal to minus 2 minus root 2. So just in common we can take minus outside, then we can write it as 2 plus root 2. So the value of k, what is the value of k? K is equal to minus of 2 plus root 2. Okay, this is also the answer only, but here two negative signs are there. Just we can take common and we can write the answer. So k is equal to minus 2 plus root 2. Okay, so in this problem already it is given x minus 1 is a factor of P of x. So you can take that P of 1 is equal to 0. The value of P of 1 is equal to 0. So equate to 0 and find the value of k. Let us see the next problem. Here, the same way P of x is given as kx square minus 3x plus k. Already the question is given that x minus 1 is a factor of P of x. What is the 0 of x minus 1? It is plus 1. Okay, 0 of x minus 1 is 1. So in this problem also we can write that P of 1 equal to 0. Yes, now substitute 1 for x, k into 1 square minus 3 into 1 plus k. It is k here. Okay, so just write it as k. So see here, k in place of x we replace 1. So k into 1 square minus 3 into 1 plus the constant k. We have to determine the value of k. We can equate this. K into 1 square is 1 minus 3 into 1 is 3 plus k, which is equal to 0 because P of 1 is equal to 0. So we can equate the value of P of 1 is equal to 0. Now find the value of k. K into 1 is k minus 3 plus k equal to 0. See here, two terms are there. K. So k plus k is 2k minus 3 equal to 0. 2k minus 3 equal to 0. but I want the value of k. So keep 2k first here, minus 3. If it moves to the next side, it will become plus 3. Minus 3, if it moves to the next side, it will become plus 3. So 2k is equal to 3. So k is equal to 3 by 2. How? 2. I want only the value of k. So 2 is under the multiplication operation here. If it goes to the next side of the equation, it will become division. Okay. So k is equal to 3 by 2. It is not able to simplify. So that's our final answer. K is equal to 3 by 2. So children, based on this problem, okay, we have solved the first, second and third problem in exercise 2.4. Based on this problem, we will be getting your assignment PDF. Okay. Do the assignment problem. Thank you.